Question 5. The circuit diagram below consists of a battery, a switch, an ammeter, and a glowing light bulb, all connected in series. A voltmeter V is connected across the light bulb. So according to the question, we have a battery. The battery is the power source. It gives energy to the negative charges. Those are electrons, so that they are able to flow through the circuit. The long vertical line of the battery represents the positive terminal, and the short vertical line represents the negative terminal of the battery. It is also mentioned that we have an ammeter. An ammeter measures the current strength or the electric current through the circuit or a circuit element. The ammeter must always be connected in series. An ammeter has a very low resistance so that it can allow maximum charge to flow through it. We are then told that there's also a light bulb, which is our load or the load. This means that it uses the energy given to the charges by the battery so that it is able to glow. Then we have a switch. When the switch is open, when the switch is open, it means that there is no flow of charge in the circuit. This is because the circuit would be incomplete. However, as in this case, when the switch is closed, there is flow of charge in the circuit. This is because the circuit would be complete. Now, the battery, the switch, the ammeter, and the light bulb are all connected in series. This is because they are connected along the same branch like this. Look at the black line that is going through all of these elements. All of these circuit elements are connected within that single branch. They are all in one branch. Now, what does that mean? This means that the ammeter will be able to read the current through the light bulb. So that ammeter you see there will be able to tell us the current strength there by the light bulb. But we're not done. Finally, we have a voltmeter, and the question said that the voltmeter is connected across the battery. One thing about voltmeters is that voltmeters have high resistance. This is so that they draw as little current as possible from the circuit. This voltmeter measures the potential difference across the light bulb, and so it must be connected in parallel to the light bulb. The voltmeter, if you look, is connected in a different branch than the light bulb. Look at the red line. It's on its own separate branch, and that's why we say it is connected in parallel. The voltmeter is on the red branch, the light bulb is on the black branch. The voltmeter is connected parallel to the light bulb because both the voltmeter and the light bulb will experience the same potential difference. Hence, the voltmeter will be able to tell us what is the voltage across that light bulb. Question 5.1. Define the following terms. 5.1.1, potential difference, and it's a 2-mark question. 5.1.2, electric current, and it is also a 2-mark question. These two questions are what is called recall or remembering questions, meaning that we just need to remember certain definitions that we learned maybe when we were studying the topic. So now we can describe potential difference across the ends of a conductor as the energy transferred per unit electric charge flowing through it, and that is how you'll get your 2 marks. We can then define electric current as the rate of flow of charge. That is also another 2 mark. It is very important for you to remember definitions or to memorize them before you go write your control test. Question 5.2. The reading on ammeter A is 0.6 amperes. 486 joules of energy is transferred to a light bulb in 3 minutes. Calculate the reading on voltmeter V. This question carries a lot of marks, and this should tell you that you will probably use two expressions or equations. So the ammeter is connected in series to the light bulb. This means that it will experience the same current as the light bulb. So if the current through the ammeter is 0.6, this tells us that the current through the light bulb is also 0.6 amperes. They are connected in series. Circuit elements connected in series experience the same current strength or the same electric current. Now, 486 of energy is transferred to this light bulb in 3 minutes. This means that the work done is 486 joules. Now, we need to determine the potential difference V across the light bulb that the voltmeter will measure, and that will be in volts. We have the current through that light bulb, we have the work done on that light bulb, we also have the time. We need to now figure out the potential difference across that light bulb. So we are given that the current through that light bulb is 0.6 amperes. The work done, W, on the light bulb is 486 in 3 minutes. This means that the change in time, or delta T, is 3 minutes, but we must convert this to seconds. How do we do that? 1 minute equals to 60 seconds. This means we will say 3 multiplied by 60, and it will give us 180 seconds. We will solve this problem using two equations. So let us use this triangle to derive the expression for charge. So we want the expression for charge Q. The charge Q is equals to the current I multiplied by the change in time delta T. Why did I say Q equals to I multiplied by delta T? We need to also derive another expression for the potential difference, and we will use the following triangle. So we're trying to find the potential difference, and from this triangle we can see that the potential difference V equals to the work done divided by the charge. So that is V equals to W over Q. So now that we have these two equations, we now can substitute the expression for Q, which is I times delta T, into the second expression, because you can see that that potential difference equals to the work done divided by the charge. Now, this means that we will have V equals to W divided by, and in place of Q, we will write the current I multiplied by delta T. If you look at this new equation that we've derived from both these expressions, you can tell that we know the work done, we know the current through that light bulb, and we know the change in time. This means we can just now substitute the known values, and we have that the potential difference V equals to 486 divided by 0.6 multiplied by 180. If you put that in your calculator, you will find that the potential difference across that light bulb that the voltmeter reads is 4.5 volts. Wonderful people, we have come to the end of this question. And now, I think in terms of the mark allocation, you'll get a mark for the first expression for the charge, another mark for the second expression for giving the expression for the potential difference V, a mark for substituting this the expression for the charge into the expression for the potential difference, and another mark for converting. So you converted that 3 minutes to 180, you'll get a mark for that conversion. And then another mark for substituting the correct values in your expression or in your equation. And finally, the 6th mark you will get from the right answer. Thank you so much for watching.